Welcome to Hunting Bugs with CodeWalker. Today we're going to use CodeWalker to find a bug in my own code. I did record this intro after I solved the problem, but in a few seconds you're going to see what it's like to use CodeWalker to solve a real-world bug in real time. I also stopped recording at one point to change the UI for retrace. So once we get to retrace, the UI is slightly updated. Aside from that, I had no idea what I was going to find, no idea what I was getting into, and feel free to laugh at my expense once I figure out exactly what I'd done wrong. This bug is in C# code, and the other tools we're using here are Visual Studio and Unity 3D. Also, this is what the code is supposed to do. And this is what the code did when I recorded this. It just locks up hard. Had to force quit that. And on that note, let's jump in. The first thing I usually do is load all of the suspect code up in 3D mode just to get a feel for the scope of this project. To do that, I'm navigating to the highest point in the source directory that has a source file and selecting that. Then I'm making sure it loads all the files. From here, I can immediately tell that one file has a lot more going on in it than the others. If I didn't know my way around the code, I could tell from just this that the developer probably spent a bulk of their time here. But looking over this in 3D mode isn't really going to help me figure out this particular bug. So I'm going to switch to microscope mode. This lets me inspect one file at a time and learn exactly what's going on. So here we are in microscope, and I want to stretch out these labels a little bit, and then I want to shrink them down and see if I can fit a little bit more of this on one screen at a time. Now, as you can see, this is what all the code does for this one file. Now we could go look at that code itself, and it looks like this. There's not a lot to it as far as number of lines. This is only about 300 lines of code. But if you look at how that code actually interacts with itself, it does quite a bit. I'm going to start here at the base, and we're going to zoom in on that, CW Mesh Spinner, and I'm going to click on this little pop-up menu here, and I'm going to collapse everything to one level. And this shows me, from this point on, it's showing me that this is everything that this code does. It's got a test, draw triangles, find closest unused point, make triangle, etc. Okay, and I can move between these and look at them if I wanted to, but we just kind of basically, I'm trying to get a feel for what all this code does. And now that I have that, I'm going to expand it all back out. Okay, and now what I want to do is I'm just going to want to trim off everything that isn't code that calls itself. In other words, I don't need to know the actual, I don't need to see the actual function calls, the method calls in this case. I just want to see how I want to see those method calls in the context of which they're used. So I'm going to click the trim button to do that. And now as you can see, it has simplified this considerably. So if I were to look at this code, just looking at the raw code, I can't really tell what all it's going to do. I don't really get a sense of what it's going to do just by just kind of casually looking at it. Now, if I study this code long enough, then I might make some, connections. This call goes into this one, and this one in turn is going to do some stuff. Okay, this one is called before this loop here. Okay, well, I can come over here and get the exact same information kind of instantly just by looking at it here. So I can tell already that I can tell a few things. Let's zoom in here a little bit and look. I can tell, for example, this right here is a loop, and we've got a bunch of other nested loops in here. I can go to my filters and I can do a heat map, and this is going to show me the areas of the code that need to be the most performant if I'm really interested in that. I'm not actually interested in that right now. I'm going to click on calls though, so I can kind of colorize this and just see the different calls as they exist. So what I am interested in is why this particular piece of code is not working. Now there are two ways I could go about this. I could read over this and try to learn it and try to sort it out myself. And that's not that difficult on a small set of files like this. And if I learn exactly what the code is doing, there's a good chance I'd be able to solve why it's misbehaving. But I don't want to do that because that sounds like it might be a lengthy process. Instead, I would rather know exactly why the code is not behaving properly. So we're going to use a feature called retrace. Now, retrace, the way this works is it takes your current file and it's going to automatically generate another file that's the exact same, but it has a bunch of special calls in it. And this is going to be found in your CodeWalker files folder. And we want to take the one from today, which would be this one right here. We'll delete this other one that we just generated. And what I want to do is I want to replace in my project, I want to replace that particular piece of code. So I'm going to do this. I'm going to find it on disk. I'm going to move it. Actually, I'm going to make a copy of it and dump that on the desktop. And then I'm going to take the other file in the CodeWalker files folder, and I'm going to rename this to the name of the file as it was. I'm going to copy that, and I'm going to paste that in here, and that will overwrite the old one. Okay, now immediately I'm going to get some errors as soon as it tries to do that, because if you go in here and look, you'll see that this file is now modified heavily, and it has some stuff in it. The file is a CodeWalker retrace augmented version of this file here. Well, we don't need any of that, so we can delete that. Please back up that file and safely hide it away somewhere. This, by the way, explains everything I'm going to show you here. We want to add these statements here, so I'm just going to uncomment those. And I want to add this string to the to my class variables. And I'm going to delete this one out of the class. We don't need that. Let's see. I do want this function here. Okay. So you can read over this and see exactly how this works. But what I want to do in this case is I want to make it so that it continuously writes out that retrace file. Okay. And to do that, I'm gonna kind of borrow some of the code from both of these. I'm gonna go in here and take this, and we'll do like this. And in fact, I don't need this at all in the there. Okay, so let me explain what I just did. We're going to grab some information here, and this path here, I'm going to make a path straight to my desktop. So users. Now, the reason I'm showing you this whole system is I'm trying to get across the point that you can actually adapt this system to whatever you're using. If you have a server issue, if you have an issue on a mobile device, if you have an issue on a VR headset, it really doesn't matter what you're on. All you need to be able to do is write out this file, this special file. So we've got this. We're going to call it ttt.text. Okay. Okay. We can just make it real simple. There, I have hard-coded the path I want to write it out, and I wanted to append it so this call here is actually going to be true. That's a Microsoft call there. Okay. Now, since I'm using the debug libraries, and this is specific to Unity, it's going to be confused by this. So what we want to do here is change this one to Unity Engine Debug. Anywhere I'm using a draw line command, I want to do this. Okay, is there anything else in here? Nope, that's good. All right, well, I think that just about covers it. Now, see these little lines here that all the T's? This is our theoretically clever way of allowing CodeWalker to run your file, but not really. I mean, to monitor it and to skip some stuff. So anything called this is exactly the 5 T's. Any function call of that is completely ignored by CodeWalker. And we don't need our breakpoint here. And so what we've got is all throughout this, anywhere that there's a function call or anything of interest, it's inserted one of these little lines. Now, in some cases, we're kind of curious about like here, walking the edges. It would be useful to know how many edges we're on, right? So we might do something like this. We could pass in a text string, and we can say line I of that many, right? Any text that we pass in, CodeWalker is going to use in a pretty cool way. So we'll look at that in just a moment. So we got that, and let's see anywhere else that we have a loop we want to take a look at. So here's a loop. Let's do that here too. Triangles.count. Okay. Here's one. Here's one. We'll change that to point I. Same up here. This is a note to ourselves, is what this is. CodeWalker is only going to display this to us. It's not actually going to. It's only going to display this to us. It's not actually going to use it for anything meaningful here. Start X. Well, I don't think we're calling this. I think this is an old function. I better make sure though. That's called from this. That's no longer used. Yeah, okay, so I can ignore that one. Okay, I think I'm good. Save that. Let's go into CodeWalker. Now we're actually gonna reload this. So we're just gonna jump back out, hop back into 2D mode, pull that back up. Okay, so open retrace. Oh yeah, we need to actually run it first. Okay, so we're gonna go into Unity, and we're gonna run this with our augmented file. And in theory, it's gonna dump a file out onto the desktop called TTTTT. There we go. And we modify the sense distance. So it's running just fine. It's very responsive, somewhere under 2. We get a little higher than 2, and all of a sudden it's locked up now. Okay, so I'm gonna force quit it now. And as you can see, it has written out 1.8 megs of data. So it's been churning. And if you want to look through this and see what it is, you can. It's pretty easy to do. You just look. It's just a text file. But this particular format, where it's a line number followed by a space, I think it's a tab. It's documented somewhere. Yeah, it's line number, tab, and then text is what CodeWalker uses for this. So this is kind of cool. We're going to go in here and grab that file and load it. Takes it a minute to do this. So what it's doing is it's taking that file and those line numbers, and it's matching it up to a generated event history that it creates based on that file. And so in a minute, when it's finished, we'll be able to scrub through exactly what the program did and see how it worked. Okay, and now we've loaded our retrace data. So we're going to hit play. That's jumping around a lot, so I'm going to turn off snapping so we can just see what it's doing. And I'm going to turn on the retrace filter. I'm going to shrink this down a little bit so I can kind of see what's going on a little better. Hit the calls button a few times just to give us a slightly different view of this. Okay, so here at the beginning it looks like it's mostly up there, but if we go to the retrace filter, we see that everything's gray except, I mean, the red parts are down here. That means that when we get farther down, yeah, we're just sticking down here in the red at the bottom. Okay, so this is where a bulk of our time is being spent, obviously doing whatever it's doing there. That's interesting. But there's a whole lot of code here that I don't necessarily want to look at this. So I'm going to open the filter and I'm going to go to I'm going to hide stuff based on retrace. So that's under the hide or show parts of the code that are in use elsewhere. We're going to hide this. Now, what I'll show you first though, if I wanted to, I could trim it, and trimming removes all of the functions or the function declarations. So it just shows the functions in the context that they're actually being used, which is kind of interesting. So you can see we're mostly one or two levels deep into the class doing some stuff. Okay, so let's go straight to hide everything. Hide everything that's not the areas that are being run that retrace is tracking, and we're going to collapse all of this down and make it real small so we can hopefully fit more of it on the screen at a time. Okay, so we're going to pause this, and one thing you notice is that we're down here in this red section a lot, but we started up here, and this was all the same algorithm. So for some reason, at some point, things change, and I'm not completely sure what. I'm going to hit play here. One of the other things I notice is that when I look at the numbers here, one of the edges is, yeah, look at that. So edge 3,288 of 9,500, that's a lot. Why? There aren't that many points. There are like 10 points that we're generating the edges from. There's no way that this number is correct. So why is this happening? Now, when I say it's not correct, obviously to the computer, it is correct. To me, the human, I have messed up something. And that's what we're trying to figure out here. What did I mess up? So this is checking edges. Huh. Okay. I have a hunch. It's not a... This is a little embarrassing if I'm right about this. So I'm checking edges. If edges is that large, I'd like to know why it's that large. So I'm going to do show all. And we're going to pause it there. Yeah. Okay. Edges. Edges are the problem here. The number of edges is wildly wrong. So we're going to open variables and take a look at edges. Now, the plus tells us that's where this variable is created. Okay, so it's created up here. And then we access it a few times. Over here, we are adding some points, or adding some edges. That makes sense. And then down here, we are using edges for our loop. Up here, we are grabbing an edge out of the loop. And I think this is our problem. Yep. Down here, we are adding more edges to the edges. Okay. So what this means is I am looping through my code through this number of edges. Okay. But in the process of looping through that code, I am actually adding more to those edges. And that is a huge algorithm mistake. There is no way this is correct. And at this point, this is a good time for me to say, I have royally messed this up, and I need to rethink this at a fundamental level, because I'm adding edges inside one function that's being called from another function that's being called from a loop that is counting the edges. That's terrible. Okay, so that explains, though, why if we look at the retrace, it's red in here, because we are actually adding, every time we loop through this, we're adding more edges to this. And that is hilarious. Well, I hope you have found this to be informative, and hopefully this kind of mistake, if you're making the same kind of mistake, you'll be able to find it using a similar technique. I am now going to go and rethink this whole thing, because it is clearly not a simple typo kind of error. This is actually a pretty significant one. But that's how you use CodeWalker to find stuff like this. And if you notice, this is actually called, it is, let's go back to the calls filter here so I can show you this. This is a function, make triangle. If we go look at the code, here is that function. Here's where we're adding to the edges. This is making sense now. And we're calling it from this function, find closest unused point for edges, right there. And that function is being called from our loop. Look at that. And that's how you make a mistake in programming. It just never crossed my mind that I was making this mistake. Now, there are a lot of ways you could avoid this with different design patterns, and I'm sure that a lot of people who watch this will say, "Oh, obviously this is a trivial thing to fix, and why did he make this kind of mistake?" But the reality is, I think this is actually a very common type of mistake that you make. And with a tool like CodeWalker, it makes it pretty easy to actually find and locate. There you have it. You can get CodeWalker on Steam right now. And if you do, please drop by and say hi, and good hunting.